I run R&D at SoftServe, and within R&D we create new technologies. Right now we're building machine empathy. It's crazy difficult, crazy cutting edge. I'll describe you how to approach building intelligent machines for your needs. So, we always wanted to build machines that do some work for us. This is a steam machine, maybe still up and running. Then we built mechanical machines, then electromechanical machines, even huge. Then we reduced mechanical part and increased electrical, and we came up with building intelligence, digital intelligence. IBM Watson. So, not only intelligence is digitized, there are 7 more technologies which are digitizing exponentially. Biology and biotech already bypassed the threshold from natural into digital, and now we are moving backwards from digital into natural. Synthetic biology, biological engineering, it's already possible to take the genetic information from the nucleus, edit it, append with what we need, put it back into the nucleus, and cells will reproduce billions of times, and new proteins will be synthesized according to that linear code. So biology already became informational science. Medicine and longevity. We want to live long, we want to live healthy. Medicine is digitizing from quantified self, and again from DNA to treatment of tumors. Each tumor has its own DNA, so we could make it digital, figure out how to treat it, synthesize vaccine, and put it into the tissue. It's possible to take the virus somewhere overseas, digitize it, transfer here into the lab, synthesize this virus, invent vaccine against this virus, then digitize this vaccine, transfer it back overseas, synthesize vaccine, and kill that virus over there. Robotics and automation, not only physical robots. This year, maybe next year, is the year of bots. It's programmatic robots. Digital people, maybe they're still a bit stupid because it's not so easy just take your website or web service endpoint and substitute it to the bot. No. You have to apply machine learning, put some real human, and that human should fix the bot and label all those answers. So all those bots should be humanized first. Well, networks and sensors, also digital. We still don't have enough sensors. In this interior, we probably got to have 1,000 more sensors on our clothes, on our bodies as well, maybe inside, outside. So all those sensors must be wireless. All those sensors must charge from wire, Wi-Fi for power, not from all those kind of wires, just from the air, from radio waves. Fabrication, 3D printing, also extremely digitizing. Intellectual property moved from the physical model into the digital model. So you know how to produce it, and producing it on some printer will be just a commodity. Nanotechnology and materials definitely needed, especially for storing the sun, solar, and wind power. We could generate a lot of energy, we could just not store it. So we need new materials. To fix some parts of our bodies, we need some new materials. So all this stuff is modeling at digital level, like fitting molecules and atoms to each other. Computing and HPC. If you need to compute something, you definitely need a lot of computing power, so it will be cloud. I would personally ask you not to do designs like device cloud, mobile device cloud. It's not different from client server. So in the cloud, do high performance computing, take a lot of data, run a lot of machine learning, and so on. For those local communications, mobile devices, sensors, use mesh networking. Mesh networking is just peer-to-peer, dynamic, distributed, decentralized networks. Think about technologies like blockchain, BitTorrent, telehash. No need to synchronize with cloud. So, and artificial intelligence. It's going to be digital. But before describing digital artificial intelligence, I would like to mention you real biological artificial intelligence or natural artificial intelligence. Corporations and governments are real intelligent machines. They are intelligent machines and they are not digital. Culture, it's also kind of intelligence. But digital, of course, should be better. So, what AI is? Artificial intelligence is too wide term and not so well described. If we improve our skills with new digital machines, it could be just amplified intelligence. For example, Google as memory prosthesis. Really cool, we could look up everything in Google, and it's like picking up it from our wet brain. Another intelligence as well. Those machines are different. For example, Facebook Faces could recognize 1 billion faces really quick and really accurately, and human could not do it. So it's really different intelligence. Even if we were shown 1 billion faces, we could not recognize them when we show them again. The shape of intelligence is different. Deep Blue that defeated Kasparov in chess was some boxes and refrigerators. Watson, we saw it on the picture, it's 10 black racks and 2 huge refrigerators and a lot of noise in that room. The Google Images, it's the farm of 16,000 servers that recognize the cat. It did unsupervised machine learning, clusterization, and they recognize this entity repeats here, 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 here. It was cat. Why cat? Because we people, we upload selfies, cats, and food into the internet. So all those imagery used for training, for creation of another intelligence. What we put into the space, all those probes, they are robots. They are definitely non-organic, but they should be smart. By the way, if somebody observes some UFO, don't pretend to see some green man. No. Organics is really poor for space travel because of temperatures, minus 200 degrees, plus 200 degrees, radiation, ultraviolet, time, need some food, blah, blah, blah. So if something comes here, it's probably a robot. It's another intelligence, digital intelligence or some silicon or metal carrier. So if intelligence needed, yes, it's needed, because we want somebody to do some work for us. We created mechanical machines, and now we're creating mental machines. And this is second machine age. Those machines, like tools, are used by us, by humans who are still creative and who want to extend our powers to do another type of work with mental machines. That's why we are creating it. Should we be concerned? I think no, and here's why. First of all, the smartest people on the earth, they are not the most harmful. So if we create really smart intelligence, we should not be concerned it will be harmful. On the other side, artificial intelligence historically was created to make decisions, but being good at making decisions does not equal to do better decisions. So it's different. This artificial intelligence that we created and already put into our solutions, it does not want to do that job. We want it to do that job. We put our want into that intelligent machine, and that machine does the job. So all those intelligent machines are super screwdrivers. We just want them to screw all those things. So what is more important? Algorithm or data sets? Algorithms probably very important, but data sets are absolutely important. DeepMind, the company, $500 million from United Kingdom, was acquired by Google. They used algorithm that was 18 years old to equal human player in Atari games. And dataset from simulator from Atari was only 3 years old. As soon as it was made available, the DeepQN algorithm worked. And average time between making dataset public and some real breakthrough with artificial intelligence is only 3 years, now even less, 2, maybe 1. And all those algorithms, they were for years, 20 years easily. So, data sets, data, where to find data and what to do with data. Well, you want it?
Can you explain a little bit more about the previous data?
Do you drink beer? We could continue over there at the bar. So, where to take the data? Okay, you could write the logs, a lot of logs, and you'll have a lot of data. But is this big data? Is this enough data? What makes data big? The critical mass of the data that gives us probability of some events. So as soon as we are sure that this event will happen with this probability, this data is big enough for us. We don't need bigger. Definitely, if it's smaller, it's insufficient. How to find this data? Let's look. Social. People are all duplicating themselves digitally. We are on social networks, we are connected to each other, we comment each other. There is huge social graph. We could take this profile and know connections between each other, like family and friends, colleagues, acquaintances, and so on, some life events. So profile of Facebook could be maybe 200 megs, a lot. But you need this data. Everybody is different. We have different interests. And those interests are structured also hierarchically. For example, I like take pictures, but I like take pictures of nature, and that guy like take pictures of people. So everything structured hierarchically. So we need some graph of interests. We could merge social graph and interest graph. Interests and people will be nodes, and everything else will be relations. Independent of our interests, our intentions are different. Okay, I love to take pictures, but I have intention to drink the beer. So intentions are different. So there is whole intention graph. Independent of my and your intentions, we consume differently. Consumption graph, what we buy or what we take for free, because we could consume for free as well. With consumption, situation is really difficult. If interests, intentions, and everything social could be grabbed from that user in your ecosystem, consumption is behind walled gardens, in the walled gardens behind the walls. Amazon, eBay, Alibaba, they're not disclosing who buys what. It's impossible to take this data, but those guys have really cool consumption graphs and they make use of it. Other guys who have consumption graphs, Visa, MasterCard, American Express. Really cool information, and probably we have to find the hole how to take at least anonymize that information for some consumption patterns and so on. Okay, independent of our consumption, we could be in different locations, and in different locations we change our behavior. So we have motion graph, how frequently we travel, how long we stay at some locations, solo virtuoso or as a team, and so on, so on, so on. So there are other graphs as well. For example, if we take medicine and some really deep medicine, which is also digital, like genetic medicine, there are graphs as well. Relations between genes, all those patterns. If we take logistics, there are other graphs, telecom, we have graphs in telecom, but those are pretty general. And you could think about them for your main cases. So the sixth graph is knowledge graph, a super graph when you combine all the stuff together. And Google is building knowledge graph. Facebook is building knowledge graph. Everybody is building knowledge graph, where everything is around people, because everything on this earth we're designing for ourselves. So think about filtering one graph by another graph, by another graph, funneling, 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 to figure out what is needed in the context. It's called context awareness. Well, to take the data. We have a lot of transactional data. We have era of transactional computing, and this era is ending. There were actually 3 eras of computing. People were called computers. Maybe some of you remember those times. Some of you started after that, but real humans were called computers. Then machines started to compute. And now we are shifting into cognitive computing. It's for programmers, it's switching from if-else to fit-predict. If the logic was if-else, case switch, 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 now we have to take some data, fit it, and then predict, because otherwise it doesn't work anymore. Transactional data will remain, but we need new type of computing. So a lot of transactional data at enterprises, really a lot. All those enterprises running Oracle, SAP, all the data is definitely transactional. Just know it, think of it, take it. Crowdsourced data. This was phenomenal. This was new type of data. Nobody believed that people, not paid people, could make something useful, but they did. They did Wikipedia, they did OpenStreetMaps, they produced a lot of comments and suggestions and education on forums, public forums, and all this data is really useful, and you could use this data. So think about crowdsourced data, all those open data sources. Could be some tricks with licensing. If you want to chase something in the data, you have to release under the same license. But majority of the data is okay to use for commercial purposes. Social data are really popular right now, not only on the web, also within the applications. All those new type of applications like Snapchat, probably not so popular at your age, but a lot of guys using Snapchat, and Snapchat is becoming media company. So a lot of content is going on there, even if that content is disappearing because it's transient, you set the countdown timer, the meta information could be retained. Who sent to whom, when, what type of data, what content, was it some chat or was it photo and so on, photo, clean photo, photo with filter. So all this data could be accumulated, it's social data. Search data. Really cool data because it's very related to intention graph. If we are searching for something, it means we're wanting something. So search data also behind walled gardens. Google does not disclose its data. Amazon, wherever we search, they keep this data behind the wall, but we have to use it. Within enterprises, we have search data as well. If we use tools like Confluence, SharePoint, and we search in those tools, definitely keep those search queries, it's useful data. All that dynamics, who searched, when searched, for what, everything needed. Machine data. We're installing some computers into machinery and they produce data. Cars produce data, refrigerators, airplanes, they produce data. We attach small agents to old machines called machine-to-machine to operate the old dumb machine. Because here we need interfaces like HTTP over Wi-Fi, and that machine recognizes only push buttons and some screen like on feature phones with 3-layered menu, and you have to navigate on that menu. So you have to put your agent onto that dumb machine, either it's fridge, freezer, centrifuge in the lab or so, and operate that machine, grab the data, because if we're transferring the data back and forth, we definitely could accumulate the data and take everything that we want. We even could install additional sensors on that machine and grab all that data. And grids, IQ grids. Intelligence is not so simple. We are trying to recreate our biological intelligence, and we are below maybe 4 years, maybe 3 years old. For example, really difficult task for the intelligence. If we take something squared and rotate it, the machine could not pick up all those shades. The kid will definitely continue to understand this is the same box. Machine could lose it. We switch the angle, we change the distance, shades changed, and machine loses it. So with that intelligence, general purpose intelligence, we simply don't know what to do. Maybe DeepMind guys strongly believe they know what to do, and they try the same DeepQN algorithms on Doom, which is more complicated than Atari game. But my personal opinion, there is no aha moment, because we don't know how brain works. We did not scan the brain. It's possible to scan the cortex. It's impossible to scan deep brain without damaging it. So nobody wants his brain to be damaged, so we don't know how it works. If we take our current understanding how the brain works, okay, we could model it. But here's all the weirdness of the situation. Wet brain takes less than 10 or maybe 100 watts of energy. Completely modeled brain will take millions of millions, 10 power 12. So we don't have such energy. So entire planet is going to power only one brain. So we don't know how it works. So probably those guys should pursue it. But we could concentrate on other applications of AI and design slightly different AI. Artificial smartness. Artificial smartness means that you are artificially smart like human. For example, IBM Watson. It behaves like human in some narrow niche. Or all those games or all those screwdrivers in some niche. It works within the niche, it works really smart. That machine was not smart, we make it smart, we make it want to do that type of job, and it's okay. Artificial smartness, very good for us. We're increasing number of tools, intelligent and mental machines that we are using. IQ grids is completely different. Imagine power grids with power plants, all those wires, how to distribute the electrical energy, how to consume it. This is going to happen with intelligence. It's possible for machines to crunch the data, create this intelligence on top of that data. And Eric Schmidt from Google exactly said that all new startups should take open source data, put it through machine learning, and of course this huge amount of computing should be done on cloud because it will not fit into your small home rack. Definitely no. You could do some prototype on something small, but then you have to rent the big chunk of the cloud temporarily and calculate all that stuff. So that type of data also could be used for your graphs. So you have 6 sources of the data, you have 6 graphs of the data. Just take the data, organize it properly into the graph, into hierarchy, and then filter this graph one by another, funnel, narrow down, and it will be it. So everything cool if we have a lot of data, even strange data, even behind the walls. Sometimes we don't have data at all. I work on machine empathy and we don't have the data. We're trying to recognize emotions from the skin, and sympathetic neural system is visible on the skin. You could recognize about 6-7 emotions using photoplethysmogram, using galvanic skin response, and so on. We don't have the data. We have to record this data. And in the research process, there is a slightly different approach. Just don't take requirements and apply some agile or waterfall or Kanban or continuous delivery and deliver. No, there is pathway from generic to specific, narrow down to something working, and then from specific back to generic. If it works, apply it back to the real world, to the lifestyle, to the business. So here, in the research stage design of design, you have to design exclusive design. How do you implement this research? You have data sampling, specific data. Invent how to get the data. So probably there are no devices to record this data. You could put those devices onto people, put them into the room to experience the same emotion, then grab this data from all those people from different devices, then apply some feature engineering and find invariant features between different devices and different people that are still features and that are tangible and useful to make some decisions. So if you are not doing something cutting edge, you always have the data. Think about those 6 or 5 sources of the data: transactional, search, social, crowdsourced, machine, and you'll have the data. Apply graphs, design them conceptually, because all those relations have to be somehow modeled. Maybe Mark will describe you how. So I'm switching to Mark.
Michael.
Oh, Michael, sorry, Michael.
So, are there any questions, first of all, for Vasyl?
I'm not disappearing. I'm here. Yeah. I'm from Ukraine. I live in Lviv. I work mainly in United States and Ukraine. Not so frequent to UK, but I like London. Really clean city. In comparison to New York, for example, it's sterile.
One question. My name is Andre, and about the data, what do you think about open data movements, like open source movement, like push, those companies to share more data? Like, for example, I went to UK Open Data Project, and the government trying to share everything they collect from us as society and share too. So any machine learning engineer could get the data and working on and try to find some. What do you think about that?
So I think that the more and more data will be open. Something will be regulated and pushed by humanity. For example, if governments used our money to produce some data, they should make this data public. Or not governments, whatever. If some organization used public funding, even partially, then that data must become public, because it's symmetry. For organizations that have big problems in desperate mode, and it started from such organizations, that Canadian organization with gold mine, Gold Corp. So they were just desperate. They could collapse. So they just gave the data to everybody, organized the competition, awarded the prize to the winner, and they figured out where to dig. And they really found the gold, and they survived, and everything cool. In pharma, in medicine, biotech, a lot of data also goes to such crowdsourcing for competitions. For example, on Kaggle, you have a lot of data, a lot of open data sets. People compete to solve the tasks, business problems, real life applications.
Yes, because one thing that I think about, for example, when I go to Facebook, I'm generating data.
Yes.
And the data is supposed to belong to myself, not to the company. For example, Google, I think they have the project Take Out Data, so you can download all your data, and that belongs to you, to understand that. That's one of my questions, because they make money, because we, as everybody, we generate data to them.
Yes, and the more you use this service, the more they gain. At the beginning, they have nothing about you, and they give you service for free, and you are abusing them. But after you stay in that system for a while, they're abusing you. So definitely we will have new laws, new regulations, especially with privacy. If we have a lot of sensors everywhere, and face recognition is simple, it's much simpler than chair, as I demonstrated with this box, because majority of faces have 2 eyes, 1 nose, 1 mouth, 2 brows, and so on. It's easy to track and recognize the face. So everything will be transparent, but everything should be regulated, and we will rewrite some maybe constitutions, rules, and so on. If we want them to use our data, they could use it. If we want to retain this data, they must not use it. So moral and ethics definitely will be addressed.
I was just going to say, I think one of the things I find when I hear about open data, and also in reference to your graphs, is that there would probably be another graph called an IP graph, or a data protection graph, because you might be able to combine all sorts of new data sets, but I work in health data, and you just, because of the concern of identifiability and patients' rights and things like that, it's more difficult to go and just combine nodes.
Healthcare will be disrupted and is being disrupted right now. Medicine, energy, materials, and artificial intelligence itself. And medicine also becomes information science. We did not reverse engineer ourselves. So we thought we had a soul in the heart. You could Google the image of French guy who went from the hospital without heart, with a backpack, with mechanical heart, and his soul did not disappear. We did not isolate what the consciousness is, what intelligence is. We did not cut the head from one guy and put onto another. We don't know it. That's why reverse engineering will continue and will continue really accelerated. And this acceleration is possible digitally. It's much more easy to share all those data from different hospitals, and they share. For example, Hopkins from the States share a lot of data. Boston Sloan share a lot of data. They share. In Europe, situation is slightly different because of big segmentation, but they will also share. But the more we share, the more we know about ourselves, the sooner we will fix some problems and we will live longer. We just want to live longer and healthy. And for this, we have to share our data. Anonymized, but shared.
One last point on that. I think the other thing that goes on each node apart from IP is something to do with provenance or metadata about whether that node is good data, gathered from something that was poor or
so
good.
This karma is going to self-balance in normal decentralized deregulated system with proper number of nodes. The trust will be established properly. For example, blockchain technology is perfectly applicable to establish the trust. It's difficult to abuse the system even if you have 50% of computing power of that network where this instance of blockchain works. Why Bitcoin flopped? Because 6 Chinese guys took 95% of the computing power of that network. But it's possible to run on blockchain within our here network at Codenode, and we could figure out how trust emerges, how credibility grows, and so on.
Okay, Vasyl, I think these conversations will continue in the bar after. I'm not sure I like the idea of karma and data scientists together, but there we go. But I'll think about that.
Let's map something onto graph database.
Exactly. So Vasyl's not going to go anywhere, so he'll be around later. But let's move to our next topic where I can keep you here all night, because I'm sure some of you want to get back and do some voting, if you haven't voted already.